Hi everyone, Miss Bertuman here to welcome you back. Today's lesson is all about solving two-digit by two-digit multiplication while using the area model. Let's get started. Let's think for a moment. What are different ways that we can represent multiplication? We can represent multiplication using arrays, the place value chart, and also the area model. Let's now use the area model to help us solve 30 times 25. We learned from a previous lesson that 30 can be represented like this: 10 times 3. We also know the expression 10 times, open parentheses, 3 times 25 is equivalent. It's the associative property. Since 30 times 25 equals 10 times 3 times 25, let's represent 3 times 25 first, since we already know how to draw area models for one-digit by two-digit multiplication. Here in the area model, you can see that I've represented 25 as 25. We've decomposed 3 times 25 into what two products? Give me an expression for each in unit form. Let's start here. The expression to solve this rectangle here is 3 times 2 tens. And the expression to solve this rectangle in unit form is 3 times 5 ones. Three times 2 tens is 6 tens. Or 60. Three times 5 ones is 15 ones. Or 15. We then add the partial products. 60 plus 15 equals 75. So what is the product of 3 times 25? 75. What unit does the 3 have right now? Ones. Let's change that unit. Let's make it tens. Let's find the total area by finding partial products again. In unit form, give me a multiplication sentence to find the area of this portion. 3 tens times 5. 3 tens times 5 equals 15 tens. Or 150. Do we need to put a unit on the 5? It would be ones. In unit form, give me a multiplication sentence to find the area of this rectangle now. 3/10 times 2/10. 3/10 times 2/10 equals 600. Or 600. Go ahead and add the partial products now. When you add the two partial products, it equals 750. So 30 times 25 equals 750. I'd like you to go ahead and pause the video here. And when you do, I want you to think about how the two products of 3 times 25 and 30 times 25 are related. Welcome back. How are the two products related? Well, one was 75 and the other was 750. We can see that's 10 times as much. Draw an area model to represent 60 times 34. Next, inside each rectangle, write the expression that solves the area of each rectangle. Let's write 60 times 34 vertically, next to the area model. Let's now record the partial products, beginning with the area of the smaller rectangle. 60 times 4 in unit form is 6/10 times 4. 6/10 times 4 equals 24/10. Or 240. Now we'll record the partial products of this larger rectangle. 60 times 30 in unit form is 6/10 times 3/10. And that equals 1800. Or 1800. Remember, the partial product of 240 represents the area of this small rectangle. What does the partial product of 1800 represent? 1800 represents the area of the larger rectangle. How do we find the product of 60 times 34? We need to add the partial products. Pause the video here to add the partial products. We'll compare our work afterwards. 240 plus 1800 equals 2040. So 60 times 34 equals 2040. Great work, let's keep going. Please write 90 times 34 vertically. Think, if we were to create an area model to solve 90 times 34, what would it look like? It would be 90 by 34 units. The 34 would be split into two parts. 30, 4. Pause the video here to use the image in your mind of the area model to record the two partial products below. Then solve 90 times 34. When you're done solving, explain aloud using unit language for how you solved this problem. I'll be here when you get back. Welcome back. How did you do? Go ahead and take a moment to compare your work with mine. First, I envisioned the smaller rectangle, 9 tens times 4, which equals 36 tens, or 360. Next, I envisioned the larger rectangle, 9 tens times 3 tens, which equals 27 hundredths, or 2,700. I then added the two partial products, 360 plus 2,700, and that equals 3,060. Therefore, 90 times 34 equals 3,060. For today's assignment, your must-do problems are here on the screen. Go ahead and set a timer or watch the clock for 10 minutes to complete this work. And of course, if you have additional time, go ahead and work through any other problems on the pages. For today's lesson, we solved two-digit